So we will be starting the class, or I will be continuing topic LC circuit itself. So in LC circuit, a little bit more is there. Okay, so write the heading LC circuit or oscillations. Okay, so in LC circuit, we saw that in many conditions, I think we have drawn 9 figures, and we have seen many conditions where charge becomes zero in the case of a capacitor. When charge is zero, we found that the current flowing is maximum. Yeah, later on, of course, the maximum current would try to become zero, but just before the current becomes zero, the capacitor has a charge which is equal to zero and current is maximum. And we have seen the condition where when the charge is maximum, the current is zero. Right? We have seen both the conditions. Right? So that means there is a to and fro motion between the charge and current. Right? That is, sometimes the charge is high, sometimes the current is high. Right? So there is, I can say, an oscillatory motion between charge and current's amount. Right? So when we consider a pure LC circuit, right? So for energy for infinite time, for a purely LC circuit, okay, for a pure LC circuit, for infinite time, the energy oscillates between electric as well as magnetic form. Right. So for an LC circuit, since this is oscillating between electric and magnetic form, the energy is always conserved. In the case of an pure LC circuit, right? And the charges on the plate of the capacitor is oscillating, right? Plate, when you consider just the plates of the capacitor, you can say this is our capacitor, right? Initially, if this charge was maximum here and this is minus, in between there was a step where the charge here becomes minus and here it becomes positive, right? So charge is oscillating between plus and minus value in the case of a capacitor plate. So there is infinite conditions or multiple conditions where there is an oscillation, right? But if you are not considering an ideal LC circuit, consider an impure, right? Or this is not an ideal, or I can say non-ideal condition, which is usually the practical things. Right, practical condition, when you consider, right, practical conditions, after some times due to some energy loss, right? Suppose here we are connecting an LC like this, right? Connection means you are using wires. This wire will be having its own resistance, right? So there will be some energy loss in the case of these wires. So pure all the magnetic energy and electric energies are not converted between each other. Some of them are lost. Hence, I cannot say energy is conserved in the case of practical type of LC circuits. So just like the pendulum, where you see in practical conditions there is a condition called damping, right? So just like damping in practical LC circuit, after some time the oscillation of energy stops, right? So there is many examples where we can relate a common LC circuit with the oscillatory motion of a pendulum, right? So now we are going to mathematically explain how an LC oscillation or an LC circuit is undergoing a SHM or oscillatory motion, right? So mathematical explanation of LC circuit, right? So consider initially, suppose at t is equal to 0, right? This is our circuit. So at t is equal to 0, right? Suppose we have charged the capacitor to the full charge mode, such that now the charge of the capacitor is Q0. This is the maximum way, right? And after that, this capacitor now is connected as the figure is showing. This is our capacitor, this is our inductor, right? So obviously at t is equal to t, after some time the capacitor starts to discharge very slowly. Why slowly? Because sudden discharge is not supported by the inductor opposes it, right? So when there is a charge flow, obviously there will be what? A current flow, right? So initially, suppose I draw here plus Q0, minus q naught was the full charge condition, and there was a current flow because the charge is seriously reducing from q naught value. Suppose at t is equal to t, the charge has been reduced from q naught to some value q. So how would I draw that circuit? I'll draw it like this, right? This is plus q and this is minus q, right? And the current is flowing like this from higher potential to lower potential, right? So this is our inductor. So this is plus, this is minus, this will be plus, this will be minus in the case of inductor, right? It has to oppose, the inductor has to oppose, means this will be the positive and this will be negative. Right, now a potential drop is there in the capacitor. Let's name that potential drop as Vc. Right, how will I write Vc? It is Q by C. Right, now there will be potential drop in inductor, that is VL. I will write it as L di by dt. Right, now let us say I'm going to take the loop like this and I'm going to apply KVL. When I apply KVL in the circuit, see, in the case of capacitor, the current is moving from negative to positive. That is from lower potential to higher potential. So the voltage, I will write it as plus. So VC, I will write it as plus Q by C. Right. Whereas VL is when you consider the loop like this, right? The loop is moving like this. We are moving from plus to minus. Right, that is fall in potential. So VL, I will take it as minus L di by dt. Right, so how will I write the KVL now? I will write it as Q by C. Sum of voltage or potential across a loop is equal to 0. Minus L di by dt is equal to 0. This is our KVL. Right, now we also know current is equal to dq by dt. Right, but there is change in, or I can say it is final amount of charge minus initial amount of charge by dt, change in time. Now change in time means time is increasing, so dt is positive, but you know final amount of charge is less when compared to initial amount of charge. Thus dq by dt is minus, so I is supposed to be written as minus dq by dt. Clear? Now I am going to substitute this value here. Okay, there is an I term, right? So there I am going to substitute. Then what the value will be? Vc, or sorry, let's change it. Let's substitute here. Right, so Q by C minus L d, in place of I am going to write this one, dq by dt, right, whole divided by dt. That is equal to 0, right? Clear? Right. Now I can write it as Q by C minus L d squared Q by dt squared is equal to 0. Right? Right. But see, I just wrote I is minus dq by dt. So I am supposed to write here minus. So this minus and this minus brings plus. Right? You will get an equation like this. Suppose I am going to divide this entire equation by L. Right? So it becomes what? I will write it as d squared q by dt squared, because divided by L, this L goes off. Right? Plus 1 by LC, or I can say q by LC is equal to 0. You get an expression like this. Now I am telling you this expression is an equation for simple harmonic motion. How can I say that? Let's take the topic from 11th. What was simple harmonic motion's acceleration, maximum acceleration? It is minus omega squared x, where x is the displacement, right, of the oscillation, and omega is the angular frequency. Now I also know acceleration is 2 times differentiation of displacement, or I can write it as d squared x by dt squared. Right? So if you don't remember this, acceleration is dv by dt. V, I can write it as dx by dt. So you will get this term. It is d squared x by dt squared. Now I am going to represent this equation here. It becomes d squared x by dt squared is equal to minus omega squared x. Right? Let's rearrange it so that it becomes d squared x by dt squared plus, let me take a rubber, plus omega squared x is equal to 0. So you get an expression. So that means this equation is based on this equation. That is, this is the acceleration for simple harmonic motion. Then this equation represents a simple harmonic motion. Right? We just rearranged it. Right? Now let us compare this equation and the equation which you have written here. This one. Both are similar. Right? In place of q you are having x. Right? In place of q you are having x. So that means you have in another term. So omega squared is for 1 by LC. Right? So I can write here inside I am writing omega squared is equal to 1 by LC. Let's keep that when I compare these two equations. Right? That means when I compare these two equations, and I'm sure that this expression is for simple harmonic motion, right? That means this equation is also for simple harmonic motion. And what is this? This equation is the KVL, or based on the LC circuit which you built or drew earlier. So that means when you consider an LC circuit, there is a simple harmonic motion, or I can say an oscillatory motion undergoing. This is the way how you mathematically explain how there is an oscillatory motion in a in an LC circuit. So if the question is asked, explain how an LC circuit is undergoing an oscillatory motion mathematically, then you are supposed to do it by this method. Clear? And see, it depends upon the mark. If the question is explain how there is an oscillatory motion, or how does an LC circuit works, and the mark is for 8 to 10 marks, that means you have to draw the entire circuit. Remember, you draw 9 circuits, right? Plus you are supposed to explain it mathematically, right? If the question is only for 5 marks, that means you are supposed to just draw the 9 figures and explain it in words, right? And the separate question is for explain how the LC circuit undergoes an oscillatory motion mathematically. Then you just have to describe this mathematical expression. Clear? Okay. Now let's move on. Now both equations are similar, and we have talked about LC oscillation, and we drew this section, right? We wrote this equation. So can't I write omega is equal to 1 by root LC, right? Now what is omega? It is 2 pi by t, or 1 by t I can write it as 2 pi f. So omega I can write it as 2 pi f, and that means 1 by root LC, or I can write f is equal to 1 by 2 pi into root LC. Now this expression which I have written here is the expression for natural frequency of oscillation, right? Clear? So this is the expression for natural frequency of oscillation in an LC circuit. Clear? Right, this is very important, guys. Even in the problem separately, sometimes it is asked. Clear? Right. Now we had the equation, remember, d squared x by dt squared, right? That means then omega squared x is equal to 0, right? I'm writing that equation. This is actually a differential equation, right? So that means of what? Of a simple harmonic motion. And that simple harmonic, so if you solve this equation, what will you get? You will get the value of x, and you already know and learned about that value of x. Remember, that is expression for wave or an oscillation. This x is equal to x naught sine omega t plus phi. This is expression for an oscillation motion, displacement. expression for displacement of an oscillatory motion, right? Remember, I'm taking it again. You wrote an equation like this and you told this is an expression for simple harmonic motion, right? And you told if you, or I told you, if you solve this equation you will get the value of x, right? Now what is x? X is the displacement of a simple harmonic motion or a oscillatory motion, and we have learned that expression for displacement in the case of an oscillatory motion is x is equal to x naught sine omega t plus phi, where phi is the initial phase, omega is the angular frequency, x naught is the maximum displacement of an object from its mean position, right, which is undergoing an oscillatory motion, right? Remember, or you would have written as y is equal to y naught if the motion is in the y direction. Clear, right? So now when you compare this equation, right, and we wrote earlier that is there is a d squared omega by dt squared, okay, sorry, dt squared, right, and then we had 1 plus q by lc, right? So that means is equal to 0. That means if I solve this equation, right, the omega square, this is q, right, sorry, d squared q by dt squared. If I solve this expression, I will get the value of what? I'll get the value of q, right? So what can I write for q then when compared with this equation? Will be q is equal to q naught sine omega t plus phi, right? So right, I just compared it, right? So q should be written as q is equal to q naught sine omega t plus phi. And I know omega's value in terms of LNC. I know Q naught's value. I can compare that depending upon time. Now the problem is, how can I find the value of initial phase, that is phi? How can I find it? Right. Now for that, let's move on. At t is equal to 0, suppose I am going to consider, that is initial condition. At t is equal to 0, let us say the capacitor is fully charged. So Q is equal to Q naught, that is maximum charge. Now substitute this value here. Q is equal to Q naught means Q naught. I have to write it here. Then it is Q naught. Here there is sine. Then omega. What is the value of t? It is 0 plus phi. Right. Now Q naught cancels. So it is 1 is equal to sine omega into 0 is 0. Right. So for what value of phi? The value here will be 1. That means phi should be equal to 90 degree or pi by 2. Right. So that means now I can substitute for phi. That is for the condition. When the condition is this one. When at initial condition, when the capacitor is fully charged, then the expression of the charge in the capacitor, which is stored in the capacitor, is written as Q is equal to Q naught sine omega t plus pi by 2. Right. Now sine omega t plus pi by 2, I can write it as what? Q is equal to Q naught cos omega t. Right. So I am telling you again, at t is equal to 0, when initially when the capacitor is connected to the inductor, or when the capacitor is fully charged, the form of charge stored in the capacitor is in the format of a cosine wave, right? Clear? Right. Now if so, the charge in the, I can say that the charge is varying with the time, right? And how does it vary? It varies as a cosine form, right? Now I can say for an initial condition, if it is not like this, that is if t is equal to 0 and the charge is not in the capacitor, but now I can say the charge is totally stored in the inductor. Now it is entirely magnetization is undergone. That means here I can write, in place of Q I have to write 0, then Q naught sine omega into 0 is 0 plus phi, right? Now I can be sure that Q naught is not 0, right? If I want to find the value of 0, then this term might have been 0, right? But since I can say the maximum value of charge can never be 0, right? So 0 is equal to sine phi. So for which value the phi value, sorry, sine is 0, I can say phi is equal to 0 degree. So I can write the initial expression for q is equal to q naught sine omega t plus, in place of phi I will write it as 0, or I can write q is equal to q naught sine omega t, right? So at t is equal to 0, that is at initial condition, if the capacitor is fully discharged, it doesn't have any discharge, then the can say the charge has been or had been changing in the value or the form of sinusoidal wave, right? Or I can say sine wave, right? That is, as the time goes on, it starts from sine. Now I will draw you the figure, or I will show you it in the graphical representation, then it will be much more clear, right? Now you just register it, right? That's when the capacitor is fully charged, then the charge in it varies in the cosine waveform, and when the capacitor is discharged, then the charge in it varies in the sine form, right? Clear? Right. Now let us continue. Now at t is equal to 0, right? Q is equal to q naught. We had the initial description of natural frequency as 1 by 2 pi into root LC, right? Now if the circuit had, this is something which has to be very important while solving the numerical questions. Now the circuit has multiple capacitors, then you are supposed to write for natural frequency f is equal to 1 by 2 pi root L into C equivalent, right? If you are having a circuit with multiple capacitors, you are not supposed to find frequency for individual capacitor. You are supposed to take the equivalent capacitor and just substitute it in this equation. Clear? Easy, right? Now let's move on. Now we have q is equal to q naught cos omega t, right? When this condition is there, when you have the charge as maximum, you have q is equal to q naught cos omega t. Then what will be the expression of current, guys? You know, current is equal to minus dq by dt. Why did I write minus? Because charge is going to be reduced from this point. So here I will write minus d by dt. In place of q, I'll write this expression. It is q naught cos omega t, right? So it is q naught is constant, I'll write it outside, minus d by dt, or I can write minus here, no? So let me take the rubber, right? d by dt of cos omega t, right? Clear? Now what is d by dt of cos omega t? What is d by dt or d by dx of cos x? It is minus sin x, right? So this will be minus q naught, right? In place of cos I have to write sine, so minus sine. In place of x I have omega t, but there is a omega constant, right? So I have to write it as minus omega sine omega t. So it will be minus minus cancels out, you will have q naught omega sine omega t. If you didn't understand why this omega came up, there is an equation like that. See, d by dx of cos ax is equal to minus a sine ax. You can either learn it by this form, right? You are actually in differentiating with the x term, right? So a is constant, so first you differentiate cos term, hence you got sin ax. Then you go for differentiating ax, so a is constant, so I write it out, and x cannot be differentiated. The what is dx by dx? It is 1, right? Now so I will write it as q naught omega sine omega t. Now this q naught omega I will write it as I naught. So I is equal to I naught sine omega t, where I naught, that is the maximum current which can be flown in the circuit, which is flowing in the circuit, is having value q naught, that is maximum charge into angular velocity, right? Clear? I just told you before that I will show you by the graphical representation how the waveform of charge and current change. Let's take current also. Either I can draw in two figures, but I think it is better if I draw in a single figure. Sometimes you can see in some of the books it is two waveforms. Right, let's draw it in single waveform itself. This is for our time period. This is for both charge and current. Okay. Now you know current will be having less value than charge, right? Current is equal to dq by dt, right? So dq will be large, current is less. Because charge by time is current, right? So the amplitude will be less. I just want to mention it. Okay, let's move on with the charge, guys. So first of all, let's mark x values. X is for time period, right? So you know for a single cycle, omega is equal to 2 pi by t. So t will be equal to 2 pi by omega. That is for one time period is how much? 2 pi by omega. So what will be t by 2? It will be pi by omega, right? So and sorry, let's move on here. I will rub it off later on. So half is t y by 4, full is t pi by 4. What will be t pi by 4? 2 pi by 4 is full, half is pi by omega. So what will be t by 4? 4 will be, right, pi by 2 omega. Clear? Simple. Let's move on. And what will be 3? Okay, let's move on with this one itself. I'm marking it, okay? So let's make this one as large one. So this is one cycle, 2 pi by omega. This is half of it, pi by omega. Its half will be pi by 2 omega. Right, this one will be 3 by 2 pi by omega. Right, simple. Now this is 0. Let's move on with the equation of charge. Let me rub this one. Let's make this rubber size large. Okay, now let's write the charge equation. Q is equal to Q naught, right? Cos omega. Let's start with 0. Cos omega 0, cos 0, this is 1. So you will get Q is equal to Q naught. That means at time is equal to 0, you are having maximum charge, Q naught. Let's say this is Q naught. So this is the starting point here. This is Q naught. Now next interval is when t is equal to pi by 2 omega, right? So Q is equal to Q naught cos omega pi by 2 omega. So you will cancel omega, then you will get cos pi by 2, cos pi by 2, 90 is 0. So you will get Q is equal to 0. That is, at pi by 2 omega, you have charge is equal to 0. So that means you have to mark accordingly. Then here it will be 0. Let's plot it like this. Right. Now let's move on with the next one. That is Q is equal to Q naught cos omega divided by, let's take the highest value, right? It is pi by omega. Let's take this as a pi by omega. That is pi by omega. You will get omega cancel. So it will be minus Q. Why? Cos pi is minus 1. So it is minus Q naught. That is what pi by omega. You will have minus, let's say this is minus Q naught. Right, you will have the corresponding value like this. So obviously now you can finish it, right? Right, clear? Now similarly I can draw for current also, right? How will I draw for current? Current is equal to I naught sine omega t is 0. Sine 0 is 0. The I naught will be 0. Similarly, I is equal to I naught sine omega pi by 2 omega. So omega omega cancels out. So sine 90 is maximum. So I will be I naught. In the next duration, so I is equal to I naught sine omega by pi omega. So omega omega cancels, sine pi is 0, so we'll get 0. So can I plot these three values? Let's plot it, right? So at 0, when you consider the current, it is 0 itself, right? Then at pi by 2 omega, it is having maximum value. Let's say this is I naught, right? Then obviously now I can plot it like this, right? Clear? This is for current, this is for charge. So you can plot current as well as charge waveform in the case of what? LC circuit. See, so when the time goes on, right, if the charge was maximum, it then goes by t by 4 time, it goes from maximum to 0. Then the charge then changes to polarity, right? If this was positive, this was negative in the case of capacitor, then it goes to minus and then positive. See, then negative polarity, then charge goes on to become 0. Again it gets charged to positive value like this. That is the case of capacitor, right? I hope you understood. Similarly, if the charge is maximum, obviously the current will be 0. Just that form, you will get the cosine waveform of current. Clear? This is how you learn about LC circuit.